Alright, so in this lesson, let's talk about splitting responsibilities within our app. We can see that in our project here, the restaurants activity does a lot of things. So if we go in the show restaurants method here, we can see that it gets the restaurants from the server, it parses the restaurants, it filters them, and it displays them. And all that logic is basically extracted by us here in methods that do this particular action in turn. So let's see what's the problem here. Well, our activity kind of does a lot of things. Well, it has 130 lines and it only displays some restaurants. Typically in production application, there's a lot of other logic involved and you end up with activities that are huge. So we don't want to have all the logic cramped here into an activity. You don't want to have a huge God object activity that does everything. Instead, let's have smaller classes that are specialized in what they do. So we basically split the responsibilities by doing so, and we are able to reuse that logic in several parts within the app. So if we extract, for example, a business object with the logic to filter and sort the restaurants, we can reuse that logic from that object by taking the actual instance of that object wherever we want in the app, and we're going to have all that logic extracted, so we don't have to copy paste the code. In our case here, if we are able to extract, for example, the logic in which we filter, as I said, and sorted the restaurants, we can basically take this and instead of copying it in different activities, in different fragments, we can use that object that is going to encapsulate this logic here. So this is a very good point, because if the logic changes, we don't have to change it in multiple places. So if you have copied the same logic in multiple places within the app because you needed it, right? When something changes, when the stakeholder comes and tells you, hey, I don't want you to check the closing hour against the number 6. I want you to check it against number 7. And then you're going to have to go and check for this logic and replace this logic wherever you have added it and copy pasted it in the app. So that's going to be problematic and you might miss some cases, so that's not really that good. Also, by extracting all of these methods out of the activity, you're able to have more clean code and a smaller class, and you're more able to understand what happens within that class. So we want to try to preserve and keep only logic that is for an activity, so the UI logic, right? Well, now, this is not going to be a perfect separation of concerns. And you'll see why in a moment, but mainly because I want this lesson to be an introduction for a more complex lesson where we are going to be splitting responsibilities a bit more correct by using proper view models, by using use cases, and having a presentation pattern that layers our app and that has this kind of separation of concerns really well applied within the app. In this lesson, though, we will be using plain classes just to extract our logic from the activity and make the activity lighter. So to try and split all of this in separate specialized classes. All right, let's start by extracting the first thing. So if we have a quick look here in the show restaurants, we can see that there is this logic to get the restaurants, and then the parsing, and then the filtering, and then the display. Let's start with the get restaurants method here that we would like to extract, because we don't want this logic that gets the API restaurants and actually calls the server in the activity. We want this in an API client. And we can see that we already have this. It's called restaurants REST client. So if we press Control B to get to this class, we can see that we have this method already here. Now, it only has a very interesting method that kind of gets the mock restaurants, kind of imitates a server response. We don't really care about that. But what's important for us is that we get this method here. So let's just move this method, Control X to kind of cut this code. All right. And let's go in the REST client here and paste the method that we have just taken. Now it's not going to be perfect because, as you can see, there are several things missing. Well, the first thing is that we don't want to instantiate a restaurant REST client inside the restaurant REST client. That's redundant. So this used to be the old logic. Let's remove this here. And by doing so, let's call this get restaurants method that we used to have. Let's call this get mock restaurants. Should be more suggestive. We only use this to get the mock restaurants. So let's copy and paste this here like this. And instead, let's get rid of this user ID because we didn't really use it. It was just for a mock interface. And let's just ignore that. We just care that this is a simulation of a server response, of a server request and a response of delay of 1000 milliseconds. All right, but we are still missing something. We needed that disposable that we had in activity. So this disposable basically allows you to cut the stream when you don't want to receive the data anymore. So if the activity is destroyed, in our case, here in the onDestroy, we are disposing the disposable, basically telling RxJava that, hey, I don't want you to cut this stream. I don't want to receive any restaurants anymore because this screen is no longer on the screen, is no longer active. So let's take the disposable and let's place it in our restaurant REST client here because it should be his responsibility to cut this stream. And let's have a method here called phone stop streams, or stop stream for us at least. It's enough for us to infer that is the restaurant stream. So let's go and say here disposable.dispose, and this should be enough. Let's go back in the activity and see what's the problem. Well, the problem is that in our show restaurants method, which kind of changed all of this logic, we are missing some stuff. We need a client, but we don't have it. So let's call this restaurant client like this. And let's call this a restaurant REST client that we have just worked on. So we need to instantiate this client within the activity so we can have access to its logic, to the code. And by doing so, we can come here in the show restaurants and say, well, our client dot get restaurants. And right now we basically call the get restaurants method in the client. So all this logic here is executed. We can also remove this. We don't really use it anymore. All of this logic is executed and is encapsulated here in the restaurant REST client instead of having it into the activity. And we can reuse this logic by actually reusing and reinstantiating a restaurant's REST client. All right, so let's also dispose this. So we can go here in the restaurant client here that we have and say stop stream. So if the activity goes to the onDestroy callback, we want to stop the stream. So we have successfully extracted the logic to get the restaurants from the server in our restaurant REST client, as we can see here. And let's move on to the next types of logics. We have here a parse restaurant, and let's press Ctrl B so we can get to this method, which kind of parses the restaurants and returns a domain object, the restaurant object, right? And remember that it parses the restaurants from a type of restaurant response to a type of restaurant. We want to extract this so we can be able to parse these restaurants so we can be able to reuse this logic somewhere else within the app. So what we can do, we can come here in the Explorer and let's create another class and let's call this restaurant parser. This is a good idea, like this. We can call it more generic and we can make sure that it's going to take care of this, only parsing stuff. But for now, it's enough. And let's take the logic within our activity here, Ctrl X this, like this, and basically delegate it here to the restaurant parser. And now it's perfect, but we're still missing something. Let's go back. And here we can't really call, we don't have this method. We need to instantiate a restaurant parser. So what we can do, we can basically come here and say vol restaurant parser equals, well, our restaurant parser. Let's just get a instance of this parser here so we can use it. All right, and let's call it here on this line. And right now this is working even better. He's complaining that the method is private because when we copied it, we kept it private. We don't want this to be private, we want this to be public so we can access it. And right now we have extracted or delegated the parsing logic in a different class. So right now, this logic in the restaurant REST client that we have extracted, this is basically encapsulated here so we can reuse this logic, right? And here in the restaurant parser that we have just created, we can reuse this logic wherever we want in the app. So again, we have a very good win situation in which we have kind of delegated the logic, we have extracted it into separate classes. Let's do the same thing for the filtering. And here, what we can do something pretty similar. Let's create a class called restaurant rules, like this. I guess this should be fine. And let's add the method that we had in the activity. And this is something that should be pretty easy. Control B. Let's copy only the public here, and let's cut this private. We don't need it. And going back to the rules, let's paste our new method. And perfect, we have the method in the restaurant rules. Let's also go back here and create a restaurant rules here. Like this, equals restaurant. Well, let's call this rules, right? So what we do, we basically take these objects and we make use of them with their logic that we have encapsulated inside. And right now we can see that we have a parser, which basically is in charge of parsing objects, in our case restaurant. So if we want, we can encapsulate other types of parsing logic there if we have different types of objects. And here with the restaurant rules, we have basically a business object that encapsulates the logic. So if you go here, the logic that is needed to get viable restaurants. So we filter them, we map them, and then we sort them. Going back, we only have one step to do in order to simplify our activity. We have this display restaurants method. Now, this method here has some UI logic that we can't really get rid of. This is something that it should be in the activity, right? Setting the restaurants and the clay listener. But the actual mapping from a list of type of restaurants to a restaurant display item here, well, we could actually take this out. And this is basically a presentation logic that should be in a view model. Now, if you already use a view model, I'm really glad that you do. But for those of you that don't know what a view model is, it's basically a class that helps you prepare the data to be presented. And that's why you used to be a presenter, it used to be called a presenter. It's much more suggestive that way to be the presenter. But right now we kind of call it view model. And what a view model does, it basically takes the data that it has, the domain data, so the restaurants that we handle within the app, and converts it to something UI friendly. In our case, it has a display name, it has a display distance, it has all of this data that is ready to be displayed and is friendly to the user. And what we can do, instead of using a proper view model, because I want to keep that for the separate lesson on presentation patterns and MVVM presentation there. I don't want to use a proper view model. Let's just create a simple class and we can call it a view model. So if we go and create a new class, and let's call this restaurant view model. Now, again, this is not going to be a proper view model. So by a proper view model, I mean that a view model from the lifecycle package from Jetpack Android means that the view model is tied with the activity. So it means that when the activity is alive, the view model is alive. And when the activity is dead, well, the view model is going to be dead as well. Then it's going to be null. So that's a very cool property that we are going to be talking in the MVVM presentation patterns lesson. All right, let's focus on what we have to do. We have to basically get the display restaurants. So let's create quickly a method here, get display restaurants like this. And that's perfect. But this is going to need a restaurants like this. So it takes as an input argument the restaurants that we use. And it's going to return, well, a list of restaurant display item. So this is pretty similar to what we had so far. We can take this code here, like this, Control X this, perfect. And let's remove this, we don't really need this anymore. Oops, not this one. Going back to the view model, which again is a simple plain class, it's not a proper view model. We paste the code, and right now let's return it as well, like this. And right now we have extracted the presentation logic to a simple class, to a view model. We can call it a view model or presenter, just a class that is in charge of presenting the data, of getting it ready for presentation. So let's use this view model here. So going back into the display method, let's call this view model equals a restaurant's view model. And let's get the view model dot get display restaurants, and let's pass the restaurants that we get from the filtering, from the sorting, and so. And right now, we have extracted the presentation logic as well. So all this friendly logic can be reused somewhere else within the app, and we don't have to copy paste it if we need it again. Now, of course, that if we use all of this logic, like the presentation logic that we talked about, or the business rules that we talked about, filtering, or the parser, if you use all of this only in one place, like we had it here in the activity, it doesn't make too much sense to extract them to a separate class like we did here, all of these separate classes. It's a good practice because you keep your activity clean, right? But it kind of makes more sense to do that when you have need for the same logic within multiple places within the app. It's not our case, but usually production apps have this kind of behavior. They need the same logic in several places within the app. And by extracting them, you kind of get ready for the future. You're only going to have to change in one place, well, the view model here, or the restaurant rules class, or the restaurant parser. When you have to change something, you can change it in one place, and all the other places are going to get affected, and that's going to save you a lot of time. Now, looking at our activity, let's delete this line here. Look how clean the activity is. It has, like, it starts from line 9 to 79, no, to 59, I'm sorry. So it's even shorter. It has really few lines, right? It's really easy to understand what's happening with this in this activity. It doesn't have all of that crappy code that we had initially. So there is still a problem here, and that problem is that this activity is still in charge. It's not that dumb. We're going to be talking about the dumb concept soon in that lesson about presentation patterns, but it's not dumb because it knows that it has to call this client to get the restaurants, and then it has to parse them, and then it has to filter them, and finally to display them. So our activity is pretty smart, even though we have extracted the logic, but we should have delegated this kind of chain reaction actions to a different class. The activity shouldn't be knowing how to parse first and then filter after and then finally display. But again, we are going to be talking about this in the special lesson about presentation patterns, about separation of concerns, about use cases and so. But this was a very good introduction for you to simplify your activities or fragments and be able to reuse logic by extracting that to different clients that are specialized in one operation. In our case, the view model should be specialized to prepare the data for display. This restaurant rules class should be specialized in deciding how to filter the restaurants, how to map them, how to sort them, and the parser itself should be responsible to knowing how to parse different types of objects, in our case, restaurants. All right, this has been a long video. Sorry for taking you this long.